review Friday after the face class, so you have plenty of time to study.
Next Friday?
And if there is some problem in all the exams that I have not yet covered, that I'm covering Monday, I'll hold the second review, just very limited review on the extra material that I covered Monday also at 5 o'clock.
So it'll be Friday after the paper exam for your face?
Yes. Oh,
This Friday?
hold it. Remember, we have exam. Okay, hold it, I take it back. Because the computer exam is a very easy exam. I honestly expect over 90% average. I'll be sorely disappointed if you don't average over 90%. But it's not a very short exam. It takes some time. So instead of 5 o'clock,
No, we have the paper exam.
Paper's next, right?
Yeah.
okay. Yeah, well, okay, let's make it 6:15. Let's leave 3 hours for the paper exam.
What's
6:15, Friday 6:15, not 5 o'clock.
this Friday? Next Friday? Which Friday?
Next Friday. Friday before the exam. Last Friday before the exam. Although, but I guess face people will need to eat some dinner, right? All right, 7 o'clock.
Next
7
Friday,
o'clock.
7 p.m.
Friday, 7 o'clock.
Where at?
And
Same room?
not this room,
But the
the same room we had last time in Aerospace 303. Right, that's what we had to review last time, right? No, I didn't. Kemi room. Yeah, Kemi 237. Yeah, we fit in Kemi 237. Okay, yeah. Kemi 237. Okay, so review is 7 o'clock, Friday, 9 days from today. Okay, Friday, 9 days from today, 7 o'clock, Kemi 237. Okay. All right. So. So let me do this picture. Well, actually, let's say that the 0 is here so that we can easily see it. So let's say 0 is here. It makes some sense, intuitive sense, that this distance is a safety limit. The more this distance, the more safe we feel, right? With me? What is this distance? This distance is 0 minus log of AR at I omega c. Actually, when you say AR, you can just put omega c naught. If you put the transforms, you have to put the I. If you just say amplitude ratio, you can just put the frequency, omega c. But that's the same as log 1 minus log of AR at omega c, which is the same as log of 1 over AR at omega c. The gain margin is defined as 1 over the amplitude ratio at omega c naught, or in other words, 1 over the magnitude of GOL at I omega c. And amplitude ratio is the magnitude of G. So that distance is log of gain margin. So that's log of gain. Rule of thumb. tune controllers. So the gain margin is at least 1.7. Okay. So you want to have the gain margin at least 1.7. Just a rule of thumb, but it tells you, so what's log of 1.7? So you want this distance to be at least log of 1.7. Another way you can see stability is to have gain margin greater than 1. Stability of gain margin greater than 1. Okay? Stability requires what? This less than 1. Therefore, 1 over this greater than 1. So I could have rephrased the Bloody stability criterion as needing to have gain margin greater than 1. So you are stable if your gain margin is greater than 1. But it's not recommended that you use any controller that gives you for your model gain margin less than 1.7. What is the gain margin for the Ziegler-Nichols tuning for P controller? We can calculate that. Ziegler-Nichols tuning P controller uses Kc equals Ku over 2, right? So GOM is going to be GU Ku over 2. So magnitude of GOM at I omega C naught is going to be magnitude of Gu prime at I omega C naught times absolute value of Ku divided by 2. What's the magnitude of Gu prime at I omega C naught times Ku? How do we choose absolute value of Ku? Just did that. Let me go slow. Table, you can see for P controller, I have just Kc, Ku. And Gc is Kc, therefore it's Ku. So GOL is Gu times Gc, or GOU times Ku over 2, or you can rewrite it as Gu prime times absolute of Ku over 2. With me so far? So magnitude of GOL at I omega C naught is going to be magnitude of Gu prime I omega C naught times absolute value of Ku. What is this quantity? It's 1, right? How do we get? We get absolute value of Ku as 1 over magnitude of Gu prime at I omega C. In other words, magnitude of Gu prime I omega C naught times Ku, absolute value of Ku, equals 1. Relatively simple. That's how we got it. So, what's this equal to? 1/2. So gain margin, which is 1 over magnitude of GOL at I omega C naught, is 1 over 1/2 to. Okay, so Ziegler-Nichols chooses a P controller that gives us a gain margin equal to. So it's okay. All right? And generally you find out if you test it that it satisfies gain margin greater than 1%. So is the concept of gain margin clear?
That's what GM stands for? Gain
Okay.
margin? Oh.
Not general motors. Not the used cars. Right? There's a sister concept to the gain margin, the phase margin. If I'm stable, I will hit below 0, right? We can take the other direction. When log AR is 0, if I'm stable, this should be happening at a phase lag less negative than -180. If this line hits below 0, the 0 line going this way should come above -180. You follow me? So now let's look at this distance in the phase line. No log here. This distance is the phase margin. So phase margin is this distance. What is that? Here is omega c naught, right? This is here log omega c. This frequency here, it's a frequency lower than omega c naught, is what? It's the frequency when the amplitude ratio is equal to 1. Log amplitude ratio equals 0, or amplitude ratio equals 1. So here is log of omega AR equals 1. Obviously, you can't read that. Let me try to redo it. Was taken. I'll make a big one. So, you have -180. This frequency here is what? Is log omega c naught. And you go this way, this way, this way, and if you're stable, you'll be below 0. So here is log of absolute value of G over I omega C. And log gain margin is this distance. This is log gain. For phase margin, I start from 0 and I find the frequency at which the amplitude ratio, which is the orange plot. So here, that's log of omega at which the amplitude ratio is equal to 1. Can you read that now? Claudia? John? Can you read that? And then we go up or down to here. And this distance here is the phase margin.
Oh my god.
So phase margin is phi when amplitude ratio equals 1 minus -180. Okay? That's phi when amplitude ratio equals 1. And as we have a rule for gain margin, we have a rule of thumb for phase margin. exam says tune your controllers so your phase margin at least 30 degrees. So I want this distance to be greater than log of 1.7, and I want this distance to be greater than 30 degrees. Okay? Then I feel comfortable with my controller.
All right.
Okay, let's go back to the example we had done. We had tuned a PI controller, and let's find the gain and the phase margin. Any questions before I move to the example? So, let's continue the previous example. Okay, Fridays? For the Ziegler-Nichols tuning of the PI controller of the previous example. Find the gain margin and the phase margin. So what's the very first thing that I must do? And you see, if you look at all the exams, always I want you to write down what is the transfer function you did the body plot. So the very first thing is I need to figure out what am I doing a body plot for. GOL. So I need to find what GOL is. So my GU was minus 3s minus 1 over 4s squared plus 7s plus 2 e to the minus 8s. Did I remember it correctly? And my GC, I'm saying a PI controller. So if we look at the tuning that we did, so for PI, case is minus 0.90 and tau I is 14. Two significant figures are given. So GC is KC times 1 plus 1 over tau IS. In other words, minus 0.90 times 1 plus 1 over 14. Clear, everyone? Got it. Question. So, any questions, please stop. So GOL is the product of GUGC.